Hello, you're listening to Streaming Audio, and in this episode, we're going to dig into the realities of living with Kafka and just a random assortment of facts and decisions you should know about before you go into production. And we have the perfect guest to guide us through. This week, we're talking to Jun Rao, who's been deep in the engineering of Kafka ever since it began, and he's probably going to end the episode and get back to reviewing pull requests. Before we talk to Jun, let me tell you that Streaming Audio is brought to you by Confluent Developer, our site to teach you everything you need to know about Kafka. Check it out at developer.confluent.io. And while you're learning, you can easily get a Kafka cluster started using confluent.cloud. Sign up with the code podcast100 and we'll give you an extra $100 of free credit to get you started. And with that, I'm your host, Chris Jenkins. This is Streaming Audio. Let's get into it. My guest today is Jun Rao, who is a co-founder of Confluent and a long-time engineer and committer on Kafka itself. Hi, Jun. Thanks for joining us.
Hey, Chris. Yeah, nice meeting you here.
Good to have you. So you've been dealing with Kafka since its inception, and you've kept your hands and eyes on the code the whole way, right?
Yeah, yeah. all the way since all the way since 2010. Yeah.
God, that's a long time in internet years.
Yeah.
So you must have seen a lot of use cases in production along your way, right?
Yeah. We definitely seen a lot of use cases, from various industry, from various geographic location. It's a pretty exciting time to see how the technology has been picked up and adopted pretty broadly.
Yeah, it really has. It seems to be in just about every industry going these days.
Mm-hmm. Yeah.
But the topic I really wanted to talk to you about while we're here is having seen all those projects and those design things come up along the way. I was hoping you could teach me all the things that could go wrong so that I can avoid them.
Yeah. So that's pretty a broad topic. I think our time is limited. I'll just probably share maybe a few things.
Okay.
To start with, I think the first thing, right, I've seen, especially a lot of people who are doing early adoption of Kafka, is you sort of have to narrow down a little bit the operational part. I think today, people have choices to use managed services or not, right? If you are using a managed service, actually, the provider takes care of the operational for you. It's actually much easier. There are still places people are doing self-managing. Mm-hmm. So for that part, I think a lot of people, when they started, they would just try Apache Kafka. It's actually works pretty well, right? And then it's pretty stable, gets what they want, and they'll just put the production load on that. But I think sometimes, what people forget, just I think managing a distributed system, right, like Kafka is, it can be tricky sometimes because, you have to make sure all the parts are healthy, right, together. So that's why I think you need to invest. Once you put this in production, right, you do need to invest a little bit in terms of the operational part, how you monitor things, how do you set up an alert, right, how do you have the logging, right, in place and in a way that's easily accessible. So some of the mistakes I've seen, just people are very excited, to try this new technology and put workload on that. And then it worked, right? But I think since they don't have this observability or visibility, it just, I think, multiple things, over time went wrong, right? Maybe the first thing doesn't really affect you, but since you don't have the visibility, you didn't really take care of that. But then over time, I think as things accumulate, multiple things could go wrong. Then it brought into a state where now your Kafka class is not healthy. And then at that point, maybe it's harder to react and fix it. So that's one of the things I first learned. Is I think especially in the early adoption phase, it's actually pretty useful to think about not only the use cases, but also how would you operationalize it?
Yeah, yeah. I've worked for places where DevOps stopped actually putting it into production, but it's once it's in production, you got to live with it. That sometimes the real work starts, right?
That's right. That's right. Yeah, especially as you are using this like more broadly, right? And then for like a more mission critical applications.
Yeah. Let's stay on that for a bit. If so, if you have good monitoring, do you think there's a pattern of things that tend to come up for first-time users? Things that you should be looking out for?
Yeah, I think yeah when you add monitoring, right? I think um, there are different levels of monitoring that would be helpful. I think one, of course, Kafka provides a bunch of Kafka level metrics. You monitor things like your load distribution, how many things are coming in, right? How many things are going out, and uh, are the data like replicated properly, and then maybe some of the latency metric. So these are all useful, but there are also some metric that's just independent of copy. These are general health metric for your JVM, right? And GC activity and other things. And then for your host, right? This can be network, can be storage, can be memory, right?
Yeah.
So I think you sort of need a little bit visibility for all those. I think typically, I think what you would start with maybe a few some of the high level metric we have in Kafka. The typical things we have is uh, like the percentage of the thread, right? That's busy, right? You want to make sure that's under control,
Yeah.
right? And then whether there's any offline partitions, whether there's any under-replicated partitions, right? These are some of the early indicators when some problems may arise if that's not expected. Uh, but if you see any anomaly there, I think the next level thing, is you probably need into some of the lower level, maybe detailed metric in Kafka and maybe some of the machine or process level metric to piece them together.
Yeah. How do you even begin to do that? Is that I haven't spent time monitoring a large Java service in years, but is it all JMX or is there one solution? What's going on?
Yeah, I think Kafka broker runs in a JVM, so a lot of the metric, right, in the process and in the Kafka land, those are available as GMX metric. But we also provide like a reporter, right, so that you can essentially export the Kafka metric probably in a more efficient way to any system that can be used for monitoring, whether it's Datadog or uh, Elastic, right, or whatever. I think you do have a little bit of flexibility there.
Mm, okay. So it sounds possible but painful. Let's go up a tier. Right. So beyond is there let's talk about design issues because it's not just running the thing, right? It's there are
Uh,
choices you make when designing your topic layout, should we say, data
uh,
schema. So give me some ideas on what I should avoid with that.
yeah, I think there are probably a couple of things that's worth talking about. I think one is probably on the metadata design. So in Kafka, at the low at the Kafka API level, right? I think all the events are just like bytes, right? So you have a key and value, but both are just byte arrays.
Mm,
This gives the application the flexibility that they can use any like serialization mechanism, right, to do this. So as part of serialization, I think it's useful to reason about things like schema, what data you are putting in there. I think in some of the um, early adopters, I think they tend to be a little bit loose on that because they just want to get data in quickly, right?
yeah,
Sometimes it could be just um, uh, unschematized like JSON. I think that could work for if there's just like one use case, then because you can coordinate between who publishes data, right, versus who reads the data. But as your system evolve, right? Once you have started adding like a second reader, right, or that team is getting bigger, this kind of direct communication cannot work because you could easily add something, but you forget to tell everybody, right? And then
Yeah.
things start to break. So that's why I think reason about the schema a little bit upfront, and then have some story on who owns that schema, right? And how is that? What's the path for evolving that over time as your business evolves? Will help down the road. If you don't, then what we saw, in other places, they're very excited to get things quickly started, but 6 months later they will regret it because they have to redo and rethink about the metadata part.
Yeah. Uh, schemas can be so useful for like just discoverability, understanding what your data is, right? That's where
Yeah,
types can shine. But
yeah.
also,
It's also a contract. Yeah, it's also like a well spelled out contract between the publisher and the subscriber, right? You sort of need that
yeah,
contract for the end-to-end business application to flow through.
yeah, there's a definite relationship between schemas for your data and static typing, where your compiler checks things,
Right.
right?
Yeah.
So that raises two questions. The first is, well, I always just go with Avro. Am I making the right choice? Is it always the right choice? Which schema format do I choose?
I think giving people a little bit like flexibility can be helpful. I think Avro is popular. I think in some of the like data domains, right? I think people using some of the data lake area, right? I think is familiar with this mechanism. It it has the benefit that it sort of completely uh, decouples the schema from the serialization of the data. The schema is like stored outside of the data that may tend to make the serialization more concise. It also has a little bit the story around schema evolution. So how
Mm,
to do that in a more sort of compatible, backward compatible way. So these are good things, for using Avro. I think it can be a pretty good choice. In some of the other places, if people are coming from the remote procedure call world, right? I think a lot of people probably are used to things like protocol buff, right? So it has a little bit
yeah,
different design from Avro. I think the schema is not completely decoupled from serialization. So you tend to pay a little bit space, but maybe not a big deal. It also has a little bit like story in terms of evolution. It's slightly different twist from Avro. So so that I think if this is technology that's appealing to you, I think that can also be possible.
mm,
And at Confluent, I think we have a schema registry that supports uh, both this kind of serialization as well as JSON schema, if that's your thing.
the JSON schema I don't know much about. So when's that the right choice?
I think it just JSON. I think in terms of I think JSON schema. I think it does have it is a thing. I'm not sure how popular it is, right? But it does like describe the structure of the data just on JSON data. Um, it does give you some flexibility. I think a lot of people are familiar with the concept of JSON elsewhere. And it used to be, I think, one of the downside of JSON is just the encoding is kind of verbose, right? Because not there, I think, the data is, and the schema are quite coupled when you serialize it.
Yeah, that's
So
fair.
I think with compression enabled, right? Because a big part of compression, especially if you're doing it in a batch way, it is, to really just to strip out the overhead due to those redundant schema. So you could still get some efficiency on that. I think then the benefit is just okay, maybe you can work with more familiar tools on this data.
Yeah. Okay. So is tell me if I'm wrong. Is it fair to say use Google Protocol buffs or JSON schema if that's the domain you're already familiar with. And if you don't have one, choose Avro. Would that be a fair summary?
Yeah, I would say I think if you want probably the most efficiency of representing the data, I think Avro and Protobuf probably would be a better choice.
Mm-hmm.
For some of the cases, if it's like ease of use, maybe JSON can be appealing to a broader audience if they are
Yeah.
familiar with those already.
The great thing about JSON compared to the other two is you can just read it in a text editor, right? There's no
Yeah,
binary
there's a
there.
lot of
So,
tooling right available, right? So that's
yeah.
probably the convenient part of it.
Out of curiosity, I bet you'll know this. If when you enable compression, it's stored compressed on disk? Is it compressed per event or per batch of events, or how does the compression work?
Yeah, this is controllable on the producer. I think typically it's compressing a batch of events together because I think compressing them as a batch typically gives you a much better compression ratio than compressing
Yeah.
them individually because there's just more uh, things that you can share, right? As you are encoding the data,
Yeah.
and then the
So
data
does
will be and then the compressed data uh, will be sent from the producer to the broker and will be stored in the broker in a compressed format, and it actually will be delivered to the consumer in the compressed format. It's only when the consumer application wants to read it, that's actually when we'll do the decompressing. So we actually get a lot of
okay.
efficiency end to end.
Yeah, but you kind of lose that granularity, I assume. I
Um,
couldn't send you one event anymore.
Yeah, but that's the thing with Kafka API. It's not really designed, to randomly pick like individual event. It's really, designed for streaming events continuously, right, from a particular starting point. So that API actually fits us pretty well because typically you'll be streaming new data continuously. We'll be delivering those in those compressed batches to you as they come.
Okay, that sounds fair. And the other question you raised when you mentioned metadata is there is there any other metadata? Because I know schema is the big one, but what else gets attached? What else should I think about?
Yeah, the other part, okay, the other part of design, that's a bit Kafka specific. Just I think in Kafka we do have this concept called topic, right? And a topic is partitionable. So it's something like topic in some sense is like a database table, right? So you just
Yeah.
when you design event streaming applications on Kafka, you also have to do a little bit careful design on how would you spread your data among those topics, right? So on the one hand, you need to understand topic is sort of the way of grouping events of similar types together. So that's sort
Mm-hmm.
of our container, and then that's also the unit you can subscribe to, right? That's sort of the filtering you get in Kafka. Um, on the other hand, topic is kind of a metadata that takes some resources, right? So it's not something that completely free. So you have to sort of use that a little bit more judiciously.
Okay.
So I have one of the early days I was doing some consulting. I have this interesting use case when I was talking to a user. So this company is like building. It's like a enterprise company, right? It's collecting some data for its customers, and then it needs a way uh, to send some of the information back to each of their customers potentially in real time, right?
Mm-hmm.
So then they were thinking, okay, Kafka is a good fit, right? We can just collect those events, right, for all those Kafka for all those customers in Kafka, and then we'll just read it back and then send it to those customers through some REST interface, right?
Yeah.
Then the question is, how many topics should you use, right? I think the naive way is okay. Maybe our just put each customer's data in its own topic, right? Because then I can just read them individually, right? And
Right.
then
Yeah.
send it out. So that would be fine. The only thing is, I think, how many customers can you have, right? Well, for them, I think they are already at probably hundreds of thousands of customers. They imagine this can grow into many millions and beyond, right? So then that's a challenge. Just I think having millions of those topics, right? It's kind of a little bit overkilling, right, for those, because
Yeah.
each of them does take a little bit of resources in terms of the Kafka metadata you have to manage, right? I
Hmm.
think if you had to do this for all the applications, right, then it's sort of a compounds the overhead of this.
Yeah. That sounds to
So
me like a place where they've confused topics and partitions. Is that fair to say?
yeah, I think you can sort of map those two partitions too, but I think each partition also has its own metadata. So you boils down to a similar issue. Just can you have multi-millions of partitions, right? Even beyond that. I think over time we have been increasing the number of partition support. I think with KRAP, we actually can go to the million level things, right? But it just, I think, you still have to think that a little bit. I think especially overall, right? Is that just for one application, which may be okay, right? But if every application does that, then I think the amount of metadata could still be more than you truly needed.
Right. So what's the solution for that customer?
Yeah. So in the end, we look at it. You say, okay, what are the other ways of doing that? Okay, another way to do that, we'll just put that into maybe a shared single uh, topic, right? Or maybe a
Mhm.
few of those, right? Maybe just the simplest thing is a single topic. Then you can read it off, right? And then you can send it to different customers. There, I think the only potential issue, is okay. You have lots of those customers. Sometimes they may not always be, or their service may not always be available, right? Maybe if one of the customers their REST API is down, what do, right? You certainly don't want to uh, lose those events, right? For those customers, you want to keep retrying sending them, right, to see if they are available. But while you are doing that, what about other customers' data that you are currently reading, because now they are in a shared topic, right, or partition? If you,
So you're saying you've got this consumer and it's trying to send out all the data on that topic to different customers. If one customer goes down, it's kind of got to wait for them to come back up before it can get to the next one down the queue.
yeah, because all
That's
the,
okay.
yeah, because yeah, in Kafka it's like a queue, right? All the events are delivered to you in that queue order, right? So in general, I think you have to consume all the events, right, before you read the next set of events.
Yeah.
In that case, if you can't finish processing some of the events, the typical thing, you have to wait, right, until you finish processing them until you get the next one. But that will be delaying the processing of other customers, right, which is
Yeah.
also not what you want. So that also has its own issue, although it does simplify a lot of metadata design.
Hmm.
So in the end, we look at that and okay, we can actually find a better middle ground, because I think just like in a lot of the queuing system, you have this like a concept of dead letter queue, which is you can use that for staging things, right? So it doesn't have to be a lot. For example, you can have all your customers' data in one topic, and then you have this process. But if you encounter issue, right, where you can't send data for a particular customer, what you could do, you can just stash them into another like a retry topic, right?
Right.
Um,
Yeah.
then okay, first of all, you haven't lost those data because it's buffered somewhere else. The second benefit is now you can actually unblock the consumption of other customers. They can still be real time, right? And then you can have like a separate process that goes back to the retry logic, maybe with a back off, right? And then retry those. So you can even extend that because if the retry fails, maybe you want to gradually, maybe exponentially back off a little bit more, right?
Yeah.
So maybe instead of having like one retry topic, you can have a few of those depending on the granularity of back off time. But together with this, right now, you can still solve this problem in probably a pretty efficient way. But
Mhm.
now you can actually have a much better management in terms of the amount of metadata you have to cope with.
Yep. Okay, I fear I'm gonna ask a dumb question here, but but I want to know the answer. So here goes. Why, in that situation where I've got 100,000 customers and one big topic, could I just have one consumer per customer, and then it doesn't matter if the one consumer group per customer, and then it doesn't matter if my
Yeah.
consumer gets blocked? Would that work?
Yeah, that could also work. The only downside is because topic is sort of the only filtering we have, right? Now, essentially, every customer will be reading the data for all the customer and then throwing away probably 99.9999% data, only keep like the 0.1
Yeah,
percent data for itself. So it won't be efficient because your amplification is like the number of customers. Just I think
yeah,
everybody is like reading all the data. So that's the other problem.
nothing downside. Okay, so I see how that works, but it doesn't sound like there's one silver bullet answer. You've got to understand your
Yeah,
domain a
I
bit
think
for it.
I just think you have to be aware of that the concept of topic and then its implication, and then sort of make a judicious choice, right? How you would design your application around that. Just like how you would design like a database table and schema. You wouldn't have like a million tables typically, right? Unless you have to. But
Yeah.
sometimes there are like middle grounds that you can bridge to do things better.
Okay, so where does partitioning come into that picture? Let's say I partitioned my topic by the customer ID. Does that
Yeah,
get me into any better place?
you could. I think if you have partitioning, you could definitely use more. You typically can use more consuming processes or threads, right, to do things in parallel. That often like
Hmm.
speed things up. I think if you partition them by customers, maybe it also gives the ability. Maybe you have a better chance of grouping, right, uh, data that you want to send to a particular customer. So sometimes that could help,
Hmm.
right?
Yeah. Okay, so I've got some work to do thinking about my use case. Fair
Yeah.
enough.
Uh,
Let's move on from that. So, this is a big, wide question, but what advice do you have for anyone getting started with it? What advice have you had over the years for getting started with Kafka?
yeah. Well, I think one of the things, right, to get started, I think I think a lot of places do ask this question. Is okay. How many clusters of Kafka do I need? Um,
Hmm.
so in some of the cases, I think it's convenient for people to say, "Oh, I have a particular application, I want to use Kafka for. I will just have my own cluster, right, to
Hmm.
manage." I think it makes it probably easier to adopt, maybe it'll be easier to get started, right? There's no one else I need to coordinate with. But
Yeah.
I think over time, I think we just realized, I think a big benefits of Kafka, right? It's actually allows you to sort of be this central nervous system where you can integrate the data from all the places in your organization in real time together. I think the more you can put things together in a shared environment, just the more you can share their usage across applications. Maybe now you can multiple applications, right, can share the same topics data. You can start, joining different topics data together, right, for building more sophisticated applications.
Yeah.
So so there, I think a lot of concern for people to have this shared environment, is mostly on two fronts. I think one is probably around security, access control, right? Who have access to what? If I have my own thing, of course, I can control who can access that. But in a shared environment, uh, how can we make sure the data is only accessed by the team or the application that really need to access it? Um, the second issue is probably a little bit on the isolation control, right? If it's like shared environment, how do we make sure, if a runaway application affects me, right?
Yeah.
Uh, so yeah, both are sort of valid concerns, but I think over time at Kafka, I think we have made quite a lot of advancement to make this kind of sharing more possible. So on the security side, we have added like pretty sophisticated authentication mechanism. Now you can authenticate using various industry standard mechanism, whether it's OAuth, TRS, right, or Kerberos. We support all those. And
Mhm.
then we have pretty fine granularity of access control. Once you have those authenticated user, we can say, okay, for this authenticated user, you can only read right from this topic, or maybe rewrite to this topic. Maybe you can even specify, you have to use this particular consumer group, right? So it's pretty, you have this pretty fine granularity control on who can access what. So that probably mostly addresses the first concern.
Mhm.
The second thing for isolation is I think over time we have added various quota support. So which is pretty convenient for an administrator to provide this good isolation. So you typically can say, okay, um, what's the amount of resources, right, a particular application can have in terms of like CPU, maybe network. These probably are the two big things. And once you set up, I think if a particular application is abusing the system, I think their load will be throttled automatically by the server.
Okay.
So then it's only affecting that particular application. Everyone else will be protected.
Which sounds fair to me.
Yeah. So right, because you are the one who are violating the contract. So I think with both cases, I think it actually now makes it much easier, I think, for the applications to share the data like in a much bigger probably Kafka cluster. It's not like you have to put everything in a single Kafka cluster, but I think being able to think through that and then uh, share as much as possible um, gives you sort of this bigger advantage, which is now you can allow more applications to leverage this integrated data in real time.
Yeah. It kind of makes me think of relational databases, right? Where I there are legitimate reasons to have two or three or however many different Postgres databases. But I wouldn't by default put every table or every few tables in a different database. I try and centralize it into a single thing I have to manage and then
Yeah,
use access controls to
yeah,
manage who can access what. Is that a fair
yeah,
comparison?
yeah. I think it is fair comparison. I think the database has the same issue. I think um, I think ideally, right, you want people to share on like fewer of those databases. Although in reality, I think just some of the transactional database, I think wasn't like designed to be particularly scalable. So at some
Mm.
point, you can't put everything in there, right? But in Kafka, it's a little bit different. It's actually designed as a distributed system from ground up. So it actually can scale out pretty easily. So from the scalability perspective, um, there's actually a much stronger reason for you to share because it's actually um, it's possible to do that, and then it's probably also more economical from a operational perspective to manage fewer clusters than many like small individual clusters.
Yeah, and you shouldn't get the sort of downsides you get of overloading one database, right?
That's right. And then you get this isolation, right, protection for sharing applications.
Okay, makes sense. But give me the counter argument. I'm asking you to argue with yourself here. Uh,
Uh,
when should I? When is it a good time to split off into a different cluster?
yeah, I think sometimes it depends. Also, it depends a little bit on the business domain, right? I think sometimes for business data that are never like accessed together, right? There's no strong reason you have to put them together, especially if they have different characteristic in terms of some of the durability guarantees, right, or criticalness of the data. For example, maybe you have some internal operational data, right? That probably is a bit different from your business metric, right? The business metric probably is more mission critical, right? And you probably never want to lose it. So where the internal operational metric, tend to be maybe higher volume, but I think you probably want to maybe you just want to have some best effort, right, to preserve them as possible. So there may be, having different clusters uh, give you like even better isolation, right? And then you can configure and then maybe evolve them differently. And then chances are, there aren't that many use cases where you need to access them together in a single application.
Right. So you might actually start splitting them by SLA almost.
It could be. It could be based a little bit on SLA. It can also be a little bit based on like business needs, because in this case, they are like from different business units, right? I think one
Hmm.
is more like uh, the the core production business. The other is probably more internal.
Right. Yeah, that makes sense. You touched on this in that answer. Storing data for how permanent that data is, which leads me on to wondering about. I've always found it weird coming to Kafka that the default for storing data is like 7 days. Is that right?
Yeah.
As opposed to forever until I say otherwise.
Yes.
So, first, why? Why is it 7 days? And when should I change it? And what do I do about managing the life cycle of all that data?
Yeah. So I think um, what we realize, right, in a lot of the cases, just I think applications definitely are moving to this sort of event-driven way, because everyone wants to be able to leverage the data, right, in more real time as new information are coming in. So that's sort of the value of Kafka. It sort of gives you this like feed of data, right, in real time. Now, why do you need to keep the data for 7 days? Well, I think the thing is, it depends on the application. I think some of the applications, I think you have to deal with deal with a little bit maybe with the external system, right? Maybe most of the time you're real time, but if your external system is under some maintenance, right, is not available, that could be down over the weekend, right? Like a lot of traditional database maintenance. In this case, of course, you can't consume those events, right? If you want to write to those databases, but you definitely don't want to lose this, right?
Yeah.
Having this longer buffer allows us, to resume the consumption when those external systems are back available again. Yeah, second use case is really some of the bootstrap use cases, because a lot of the think of application you are building, right, which read some of the clickstream event, build some uh, state, right, associated, so that you can do like things like recommendation better. So most of that is pretty real time, but sometimes maybe you say, oh, uh, my application load increases, right? I really want to have like a separate instance for that system. So you want to start another instance, right, for doing the exact same thing. But initially, that instance need to build its initial state, right? So where does it get that initial state? So that's where I think having a little bit longer buffer also helps, because now you can just go back, based on whatever data you need, right, to build up this initial state. And then after that, you can just switch to the incremental real-time consumption. So that's also pretty convenient.
But for those cases, you're kind of saying this isn't just a queue where events get used up and then dropped. You want to keep the data around a bit longer. But I'm also wondering, when do you say, actually, I'm keeping the data around forever? When is that a good choice?
Yeah, that's also another interesting capability in Kafka. By default in Kafka, we keep the data by time, but we also have another flavor of topic called compacted topic, which
Okay.
doesn't keep the data by time. It keeps the data by key. So in this case, when you publish each event, you will have a key and a value, and then we'll be retaining. We'll be guaranteeing that we'll be retaining the latest value associated with the key as you are sending those events. So I think that's actually one of the things I find like super useful as I was talking to some of the customers. Is it's especially useful for capturing those type of data that are updatable. For example, maybe from the change data capture log, right, from like a database.
Right.
So, for example, I think I was at the retailer once. So they have this like issue, just they have like a pretty decent catalog about its product, right? This could be like millions of like items they are selling.
Mm.
So they have lots of those different type information related to this catalog that they need to update and then keep refreshing. This
Yeah.
could be as simple things as a description of the product, right? But could be other things like the pricing, the promotion, right, and the various other aspects about this. So what they want is, just as this information about a product is updated, they of course want to distribute those information to all other places where this information need to flow through. This
Mm-hmm.
could be, all the local retail stores, could be the online data stores, could be the distribution center, right? Could be other geographic location. There are quite a few places, this information would need to be flow through. So they want to be able to capture that, and then Kafka is great fit for propagating that information.
Right.
But
Yeah.
they also have this information, which is also the same bootstrap issue. It's just, occasionally, you have like a new data, new store, right? Or you have like a new instance of your online search index, right? So where do those systems get the initial data? Because initially it has nothing. So a traditional way of doing this is, okay, maybe if you want to do bootstrap, you go somewhere else. Maybe you do a scan of the database, right? To get everything. Then you switch to Kafka to do like a more incremental thing, right? To
Yeah.
capture the subsequent changes. But just means each of those applications need to deal with two systems. That they need to deal with two configs. They have to manage those. A lot of
Yeah.
databases actually don't want to do a big scan for them because that impacts their other performance. So you already has this complexity that you deal with. But with compacted topic in Kafka, it actually solves this bootstrap problem with the real-time consumption problem nicely in a single system. Because in this case, what you can do, just you can publish all the attributes, right? You have associated with each product in a compacted topic, and then the key would be just the product ID. The value would be whatever the latest value, right? Whether it's description or pricing, promotion associated with that product. So it naturally gives you like a, a snapshot of the latest value of each of the product, but it also keeps track of the newer changes. So now, if you want to do the bootstrapping for an application, right? Um, it's pretty easy because you can just use that Kafka-based application you have been building for the real-time consumption. You only need to make one change, which is from where you need to start consumption. So you just set that to offset 0. Now you will be starting to consuming that topic from the very beginning. You will naturally just be getting like the latest value for each of the product you have, and that sort of can be used to build your initial state. And after that, you just switch to the incremental consumption as new changes are coming in. So now you can see you have simplified the architecture. There's like a single system you have to deal with, whether you are doing bootstrapping or the real-time incremental consumption.
Gotcha. So let me check I've got that, I think. So you've got this system that's where the prices of things are changing all the time and you want to spread that information around the company. You stick every single change in a topic and then they can get real-time information. And by being a compacted topic, it will throw away the older versions of each product price for you as you go, right?
Yeah,
So it's just going to hold on to the latest versions and it gets rid of that whole problem.
that's right. Because for a lot of applications, they don't necessarily care about the older value. They mostly care about the latest value associated with each key.
Yeah. Okay. I follow that. Good. Okay, so I have a couple more general questions before I let you go. One, I'll save the fun one for the end. So let me grill you just on one
Yeah.
more.
Yeah.
You've seen Kafka from the start, right? From the early days of LinkedIn to today. How has it changed recently for people using it? What's your general feeling of the evolution of the project?
Yeah, I think in the last few years, I think the biggest change is probably the cloud. So earlier, I think we have the software, right? We build on Kafka. We have some additional software from Confluent which help people uh, make the adoption a bit easier. But people still have to operate it themselves, and this can be a pretty challenge for a lot of the enterprises because the their core competence, right, and core business is not managing infrastructure.
Yeah.
And so sometimes it's actually not wise for use the engineering resources for managing things like Kafka. But with a SaaS service, right, like Confluent, we provide a Confluent Cloud, and then this service is available in all the 3 major public cloud. I think that's a pretty big game changer. You just now Confluent will be the operator of the system. So if you are adopting this event streaming technology, you don't have to manage the infrastructure. We can at Confluent, because we do this as a focused area, right? We have a lot of experience in terms of like doing things like managing the load, doing expansion, upgrading, right, balancing the data for you, so you don't have to worry about this. You can just use it, and then you can just focus on your business need, which probably is a better use of your engineering resources time. So I think that's a pretty big change. The second thing I think what we realize is I think by building by sort of moving Kafka into this cloud world, especially building it as a more like a cloud native system, we actually are creating more opportunities for using Kafka. So one of the significant change we have is this infinite storage in Confluent Cloud, because by integrating Kafka with the cloud storage resources better, we actually can provide the storage capability that's truly infinitely extendable at the reasonable cost.
Yeah.
Because we can leverage like cheaper object stores, right? Like S3 in AWS in the cloud vendor. So this actually provided quite a few benefits. I think it's beneficial in terms of cost, in terms of elasticity, because we separate out the storage from the compute. But another thing it really opened up is it actually, you can now, earlier we said, okay, you can keep the data in Kafka for 7 days, but now you can actually truly keep it forever if you want. So why does this matter? I think it matters in this. I think in a lot of places, doing data integration is kind of hard, right? So you want to clean it, right? You want to make sure you get the enough coverage, and you also want to do this in real time. So a lot of things is already happening in Kafka. So that often is your source of truth. So as a source of truth, then what happens, just in most common cases, you want to consume, just the new things that's coming in because, are pretty real time. But occasionally, for various reasons, it's actually convenient to be able to access some of the historical data. This can be for some of the bootstrap use cases, right? And I mentioned a little bit earlier. This can be used for doing some of the look back, right? If you have some application mistake, you want to redo some of your business logic to fix those mistakes. Can also be for some like auditing, right, use cases. So in those cases, I think having the ability to keep the data in Kafka long allows you to have this capability in a single system within Kafka. Historically, a lot of places, people have this perception that Kafka is redesigned like for real time, right? But you typically don't keep the data there for long. Now, for a lot of applications, what if I have some occasional historical need? Well, in that case, maybe I have to build another system, right? Maybe build on some object store to have this like historical history, right? But then it just means I think now you have to bridge the two separate systems and then reason about that. Now, with the infinite storage capability in Kafka, now potentially you can just, because all the data is already integrated and flow through in Kafka in a lot of places, you can just say, oh, for some of the data I want to have a little bit historical access, I can just keep them longer, for months, years, right, based on your need. Yeah. So then it just, I think, makes this sort of combined usage for the application, whether it's like a streaming for real time or streaming from some of the historical data, much easier handled.
Yeah. I think over the years, my two biggest problems with data storage, I think, are bad schema design and running out of disk space.
Yeah.
One of them's definitely on the developer, but to get rid of the other one would be nice.
Yeah.
Okay, perhaps I should stop on the big picture, but there's one last question I really want to ask you. Wild card question.
Yeah.
What, not counting anything you've already mentioned, what's your favorite feature of Kafka?
Yeah. I think there are quite a few interesting ones, but I would say probably the most interesting feature to me, right? I think especially accounting for all those use cases, probably would be that the compacted topic. That would be one, because in terms of usage, I think it's pretty innovative when as it's constructed, and then when people realized its capability, it definitely solves like a pretty large chunk of the use cases that otherwise would be harder to do. A second,
Okay.
a second thing I would say, if I can pick a second one, I think probably would be just a replication feature in Kafka. I think this is pretty fundamental in terms of adding higher durability and availability. And with that, right, I think now, if you use Kafka cluster, right, pretty much everybody will be turning that on, because it does give you this like a better safety net, and it allows you to have sort of more trust in the data you keep in Kafka, so that you can build those like mission critical applications on top of that. It also facilitated the building of some of the higher level data processing layer, like Kafka Stream and then KSQL, because in those cases, you may want to publish data, right, deterministically based on key. So in that case, you have to send data probably to a particular partition, and then as a result, you want that partition to be always available, right? Even though they are individual server failures.
Yeah. Yeah, you've got to have replication. If you're going to shard things for scale, you've also got to have them replicated for availability, right?
That's right. Yeah, for both availability and of course, durability as well.
Okay. I like that as a favorite feature because it's a big chunky one.
Yeah, and especially doing this in real time, right?
Yeah,
that's
absolutely.
also the biggest premise from Kafka.
Yeah, and that's sort of baked into the fundamental way it's built, rather than an afterthought.
That's right. Yeah.
Mm-hmm. Well, on that, I should probably let you get back to engineering.
Yeah.
June, thank you very much for talking to us today. It's been a pleasure.
Yeah. Thanks, Chris. Yeah. Thanks
Good.
for taking time with me.
We'll see you again. Bye.
Yeah. Yeah. Bye-bye.
And there we leave it, with my brain, and hopefully your brain, filled with bits of June's brain. We could have taken more bits of brain, but that direction only leads to the zombie apocalypse, so let's stop there. If that whole conversation left you wanting to know more about Kafka in the real world, then take a look at Confluent Developer. It's full of useful information. There's going to be a deep dive course led by June himself. You'll find it all at developer.confluent.io. And meanwhile, if you do spin up a cluster on Confluent Cloud, use the code podcast100 and we'll give you $100 of extra free credit. When you use that code, they know we sent you, and that sets up a lovely positive feedback loop. That's not the only way you can be part of our feedback loop, of course. You could always just get in touch. My Twitter handle's in the show notes. You can leave a comment or a review or a thumbs up, and we'll use your feedback to help guide future episodes. And lastly, if you want to be on a future episode, if you've got knowledge to share with us or a story to tell, let us know about that too. We'd love to hear from you. And with that, it just remains for me to thank June Rao for joining us, and you for listening. I've been your host, Chris Jenkins. We'll catch you next time.